irrational numbers from a group of numbers. Whenever we talk about square roots, we're going to talk about perfect roots too. So square roots and perfect squares go together. So we'll talk about those here in a minute. You've got 3 vocabulary words. Remember, these go in your Unit 1 vocabulary set. First one's an irrational number. Irrational number is a number that can't be written as a quotient of 2 integers. The most common irrational number that we have is probably pi, which is 3.14, and it goes on forever. We'll talk about some hints to how to find irrational numbers here in a little bit. Then our second vocabulary word, radical sign. That's a symbol that we use when we're taking the root of a number, and it's going to look something like that. That's our radical sign. And then radicand, that's the number that is under the radical sign. So we're going to draw a little arrow here and put a number under the radical sign. I'm going to use the variable x here to represent that number. That's our radicand, the number under the radical. All right, here we're looking at squares and square roots. But before we get to that, we need to talk about perfect squares. Perfect squares are just what they say, a perfect square. Here we've got a 2 by 2 square, meaning we've got 2 on the length, 2 units on the length, 2 units on the width. And a 2 by 2 square would just be 2 times 2, which gives us 4. Same thing works for a 3 squared. Here's a perfect cube, or a 3 by 3 square. 3 times 3 is 9. Same thing with 4. Whenever we put this little square root or square exponent on it, it means we want to take 4 times 4, which is 16. 5 squared then is going to be 25. Again, just as a review, and sorry my box is up here, but the square root is the opposite of a square. So whenever we were taking a number squared, we got our answer of y. For example, when we took 4 squared, we got 16. X is the square root of y. So what is the square root of 16? Well, it's 4. Whatever the answer is to a square problem, when we take a number and square it, that's the square root of that number. And again, we'll talk about the radical sign. There's a picture of it. If we come over here, let's look at some examples of square roots. We've got the square root. We use our radical sign. Remember, 81 is going to be the radicand. Square root of 81, well, the square root of 81 is 9, because 9 times 9 is 81. Square root of 64 would be 8, because 8 times 8 gives us 64. Square root of 49 is 7, because 7 times 7 gives us 49, and so on and so forth. You'll see several square roots here. Square root of 36 is 6, square root of 25 is 5, square root of 16, 4. The square root of 1 is 1, because 1 times 1 gives us 1. All right, now here's some exceptions or some different ways that we can write the square root of 36. Because 6 times 6 gives us 36, and negative 6 times negative 6 gives us 36, it's hard to tell if I just put the square root of 36 if I want the negative or the positive answer, because it could be both. So we usually try to depict that by putting the negative sign out front here if we want the negative answer. So if I say, what is the negative square root of 36, then I want to know the negative answer. If I put a positive or negative sign out in front, then I don't care if I get the positive or the negative sign. So you're going to show that by putting a positive or negative 6 out front too. Now, if we happen to see something like this with the negative sign under the square root, what is the negative square root of 81? That's something we can't answer, because 9 times 9 gives us 81. Negative 9 times negative 9 gives us 81. But we can't multiply any number by itself to give us a negative number. So negative 81, we're going to answer that as undefined. So anytime you see this negative under your radical sign, make sure you answer that as undefined. Okay, if we want to estimate the square root of a number, square root of 33 is not going to be a perfect integer, so we can estimate what that might be. I wrote down the step for estimating a square root here. Step number 1, we want to find the perfect square that is larger and smaller than the number we're looking for. So we're going to find the perfect square of something larger than 33 and something smaller. So the perfect square smaller than 33 would be 25. The perfect square greater than 33 would be 36. So if we charted those on our number line here, we've got 25 over here with our 5, and we've got 36 down here with our 6. Well, the square root of 33 is going to fall in between those two, and it's going to be a little bit closer to 6 than it is to 5. So I would estimate the square root of 33 to be at approximately, let's say, 5.6. That's approximate. So if we estimate, remember, if I tell you you're going to estimate the square root and you cannot use a calculator, you want to find the perfect square larger and the perfect square smaller, and then graph them on a number line and see where your number that you're looking for falls in the middle. Here's another example of an estimate that we did. Estimate the square root of negative 129. Well, I'm going to find the square root smaller, and I'm going to find the square root bigger. So we've got the smaller version. In this case, because we're looking at the negatives, the smaller is actually going to be negative 144. Negative 144 is further down the number line than negative 121. So negative 144, which is 12, is smaller than negative 121. We'll graph this guy on our number line then also. So where does 129 fall in there? Well, it's going to be a little bit closer to negative 11 than it is to negative 12. So we would say the square root of negative 129 would be approximately negative 11.4. We'll give it kind of a good round there. It's closer to 11 than it is to 12. All right, if I want you to use a calculator to estimate, you can do that. And I kind of wrote the directions down here. If we want either the positive or the negative square root of 40, we want to hit our second button on our calculator, then the square root button, then your number, 40. Then you're going to hit enter. You get 6.3. So we're going to round that to the nearest tenth and call that plus or minus 6.3. Remember to put the plus or minus out there because we have the plus or minus here. All right, so if I used a calculator to estimate this, I would have the negative square root of 18 hit my negative second square root 18, enter, and it's going to tell me that my answer is going to be approximately negative 4.2. Okay, now we need to hit on one more thing in this unit, and that's irrational numbers. And the reason irrational numbers go together with square roots is because a lot of times you can identify an irrational number because it's going to be the square root of any prime number. It's going to be the square root of any prime number. So because 2 is prime, anytime I see the square root of 2, I know that's going to be an irrational number. 3 is prime. So when I see the square root of 3, it's an irrational number. If I were to add up here the square root of 11, that's going to be prime because it's an irrational number. Now the square root of 36 is actually going to be a whole number because the square root of 36 is just going to be 6. So it would fit in there in our whole numbers. But anytime this number is prime, then we know that that's going to be an irrational number. The other irrational numbers that we're going to have are things like pi, things that don't, decimals that don't terminate and never repeat. Pi goes on forever, 3.1459, on and on forever. So that's why pi fits in the irrational number category here. And again, hence to being able to tell if a number is irrational, number one, if it's the square root of a prime number, or if it's a decimal that doesn't repeat or terminate.